Our next speaker is a lead developer at Big Viking Games, where he spends much of his time building the back-end systems used extensively throughout Valhalla, Big Viking's HTML5 game engine. He's a graduate of McGill University in Montreal, Quebec, and a native of Seattle. Here to share his experience with some of the technical challenges of HTML5 is Chris SHANKLAND. Let's give him a hand.
Hello. So I'm Christopher SHANKLAND, work at Big Viking Games, I'm a lead developer. So we make HTML5 games on mobile and Facebook. Specifically, when I say mobile, it's really just iOS. I don't know if you've tried HTML5 on Android, but it's not super great. So first thing, what challenges? I'm talking about technical challenges. What challenges? Because I mean, you've got HTML5, right? It's been done for a year almost. Done. It's supported by all major browsers. This is what happens if you just Google HTML5. These are the headlines you get. You write your code once, you deploy it everywhere. It's seamless cross-platform, right? It's magic. Browsers are super fast. You have no performance problems at all. It's easy. It's good. And then JavaScript, right? That's really easy to write. Super fast. No problems. Right, anyways, if there are any questions, okay, so this is the graph table from caniuse.com. They sort of aggregate features of mobile standards, or sorry, HTML standards, web standards. And so support in Chrome is pretty good on the desktop versions. It's about 92%. But it drops off pretty quickly as you get to like IE or Facebook, or sorry, Firefox, Safari. And then mobile, it's about 10% worse than desktop. So it's not fantastic. And here's actually a piece of code that implements one of the most important features for HTML5 as it pertains to games. It's called a request animation frame. It really makes animation and graphics possible. This is 7 different implementations for that. So, standards. So I've got about 3 categories I'm going to go into today. I've got tools, performance, and memory. I'm going to start off with tools, because even if there weren't performance or memory problems, you still need tools to build a game. The Chrome Dev Tools really are the outstanding choice if you're going to do anything with HTML5. Specifically, the Chrome Dev Tools have a profiler in them that really allows you to identify hotspots. They have experimental tools that you should turn on if you don't have them on. There includes a native profiler that will really tell you actually what's going on, because if you run the profiler, you'll find maybe 7% of the execution is JavaScript, and the other 93% says program. Well, that's not very helpful at all. But if you turn on the native profiler, it will tell you what it's really doing. They also include a heap profiler and a timeline panel that shows you frame times and what it's really doing. The heap profiler is how you can track down memory leaks, because even in a magical language like JavaScript, you can still leak memory. And it's really challenging to actually figure out how that happens. Another tool I'd like to highlight is the Canvas inspection tool. It's also an experimental tool, but it will go through and tell you draw call by draw call what's actually happening on a canvas. We use canvases extensively to pretty much draw anything. So it's really important to see what's going on. For example, we found out we were drawing the screen 7 times with the same image over and over. It's not great. Native profiling tools for mobile are really important. So here's a little screenshot from Instruments. This is a function called Prune live resources to size. And it's responsible for making sure that your app doesn't run out of memory. But there's a bug in it. Every frame, potentially, it will throw away decoded image caches. So if you have a compressed image and you need to draw it, it's going to decode it into a buffer, and it's going to try to draw that buffer. Well, sometimes it's running out of memory, so it gets rid of that buffer. But then it needs to draw it again. Now it's going to decode it per every frame. It's really bad. It took up 40% of our runtime. we actually get around this by, instead of using image elements as images, we use canvases. Canvases are bitmaps, and you can draw them without having, it forces it to store the decoded image. So we took 38% to 0. It gave us a frame time difference of 30 milliseconds to 7 milliseconds on an iPhone 4S. JSPerf.com, if you are doing anything that involves performance benchmarking on JavaScript, you should use this website. It's got a huge library of performance benchmarks, basically. And then every time someone visits the site, you can run a test, and it will store what browser and how fast it ran. And they do statistical sampling across the runs, and then many, many runs. So here's an example of object iteration. It's pretty straightforward. Object.keys is faster. Hooray. Our backend systems are implemented in nodeJS. So we have a JavaScript client-server architecture. Inside of Node, you can really optimize for the V8 runtime environment. So it's JIT. It's got actually 2 compilers in it. There's an optimizing compiler called Crankshaft, and then there's just regular compiler. I don't remember its name. When you run the V8 tools on your code, it will tell you why it can't optimize your code. So eval, for example, is a really bad idea if you want to have fast JavaScript. And then it will also tell you where it's de-optimizing. So as it encounters something that it's already optimized, it has to check to make sure that's still valid. It will then de-optimize and recompile your code. That's really slow. We had a few hotspots of de-optimizing, de-opt cases and just not optimized code, which we addressed. And we got about a 50% throughput improvement. That was maybe one person, 1 week of time. Just don't use eval. Hooray. And then the last tool I was going to highlight is the Safari Remote Debugger. If you're doing any kind of HTML web type of development on iOS, you really, pretty much the only viable tooling option is the Safari Remote Debugger, which came with iOS 6. It gives you a subset of the Chrome DevTools, sort of what's basic in WebKit, but on a mobile device, an iOS device. So that's nice. So I'm going to move on to performance now. And this is a little known performance trick called the Optocopter. So back to Crankshaft in V8. This is a snippet of code from our server. And Crankshaft, again, that's their optimizing compiler. It uses a string length heuristic to inline functions. Pretty typical optimization, right? Well, try-catch functions, try-catch blocks, cannot be optimized. It's just automatic. You can't optimize that. And so if you have a try-catch function in any function, that function can no longer be optimized. Now you have a problem, because try-catch functions are very small. And we tried to move it out into its own function so that the rest of the functions could be optimized. But that didn't work because it was inlining the try-catch. Well, it turns out that the heuristic includes the length of comments. So 2 optocopters is longer than that length that it checks for. This function is no longer inlined. 5% CPU improvement. 15% throughput improvement because we reduced contention. Literally that code. And I was doing a code review for this, and I saw this as the commit with like a screenshot of performance, and I was like, no. What? Yeah, crazy. Some other things that we found are function calls are very expensive, especially in iOS. So we inline functions. We just don't call functions. Or we will actually write functions at runtime. So JavaScript is a very dynamic language, and you can do some very bad things with it, but sometimes that's the only way to make it work. So we will like dynamically create a function, and that will be our hot function, because you don't want to write out the loop, or you don't know how long a loop is, for example, but you can create a function at runtime because you do know how long it is then. That's very fast, except on Chrome. I don't know if you can read. Okay, so the blue is where you call a global function. Red is where you define and call a function within the actual benchmark test. and then in yellow, orange is where it's inline. For some reason, Chrome decided that inline is going to be the slowest. Calling a function is faster. Doing more work is faster. Who knows why? But on iOS, it's much, much faster to not call your function. Branching is also very expensive. This is sort of goes hand in hand with inlining, doing less work. You can actually reassign a function instead of if, so this is our drawable container that can be drawable or animate. It can have a drawable or an animation. And so instead of saying if it's drawable, do this, if animation, do this, we just reassign the function depending on what it actually is. Skip it completely. The combination of those gave us about an order of magnitude. Like, it really made our animation system viable. And then here's the bug that I was talking about earlier, the prune live resources to size. It's still an open bug. It's been open since 2007. So who knows? They fixed it once, and then someone said, oh, but it uses more memory. Shocking. So yeah. Sometimes it's a bug. You can't do anything about it. HTML5. So the last thing is memory. And memory is probably the worst thing with JavaScript. As you may know, JavaScript's a garbage collected environment. But everything creates garbage. I mean, strings especially are the worst. They're all immutable. Every time you do something with a string, no matter what you might think you're doing, you have created a copy of it. And now it's going to be garbage collected at some point. Garbage collection can take an infinite amount of time, really. Hopefully it's fast. But hopefully isn't really good enough if you need an animation system that doesn't look janky. And so we looked at garbage collection and really how bad is garbage collection. Here is a graph from a paper showing on the bottom axis here, you've got the relative memory footprint. And so that's relative actually to manual memory management. And then the vertical axis is the number of cycles it takes, the overhead. And you'll notice that at about 6 times the memory management, you're only paying a 50% cost in CPU. As you go down to 2 times the amount of memory management, it's off the graph. You lose performance exponentially. And this doesn't really get better. When you're in mobile, iOS likes to kill your app when it takes too much memory. How much memory is actually arbitrary? We've seen it anywhere between 200 megs and 350 megs on an iPad. Cool. It's a garbage collected environment. You can't control it. There's nothing you can do. You just pray. Like, probably 5 to 10% of the time that the game runs, there's a 90% chance it's going to be killed depending on what other applications you had open at the same time. And there's nothing you can do about it. Specifically, here is a snippet from the ECMAScript specification where they state you are not allowed to know how much memory you are using at any given time. And there's furthermore comments, and there's a really long email trail that they basically say they have no plans of ever adding such a thing, because in JavaScript you should never know about the garbage collector. And if you knew how much memory you were using, then somehow that's you knowing about the garbage collector. Therefore, you can't know any of that. So you guess, and it's great. But there are some things you can do to help with memory. You can create pools of things. I mean, you sort of go back to a static memory, more like a C type of environment. Don't ever call new. Don't allocate anything. Obviously, that's not going to work. Like I said, everything creates garbage, but if you keep it to a minimum, you're going to be okay. Use out parameters. So pass an object. If you're going to need a non-primitive returned, pass something that they will set a property on. And then there's a really cool tool called Inscriptin, which will actually cross-compile. Well, it takes in LLVM bitcode, which you can create using Clang from C or C++ code, and then it will spit out some JavaScript. And they have implemented malloc and free as a array buffer, essentially. So when the program starts up, it allocates a massive chunk of array buffer. and then it uses that to push and pop and deal with stack allocations and heap allocations, actually the same way that malloc or free might do it. This does not create any garbage because you've already pre-allocated all of this memory. It's not very efficient right now. I think it operates 2 or 3 times the amount of memory that the program might actually need, which then if you think about JavaScript in the garbage collected environment, you're looking at 10 to 15 times the amount of memory you might actually need. That's not a big deal on a desktop, usually. You got plenty of space. It's not really viable for mobile yet, but we're really excited about that. Yeah, and that's pretty much it.
So now is question time. I'm sure there's all kinds of coders out there who want to ask code-related questions to Chris.
Yeah.
Hi there, Chris. I had a question about wrapping, kind of like the Sencha Touch model, where they actually are wrapping your JS in a browser that actually is memory, something you can profile. You can profile the actual running process through, dirty methods of anything from an external process to, writing literally just writing a file that you check or whatever. There's lots of workarounds. Do you have any experience using wrappers to try to manage memory growth?
So do you mean sort of like wrapping the actual JavaScript execution?
Yeah, like
So they just implement their own version of JavaScript. Essentially,
Well,
I
I mean-
haven't actually used Sencha Touch.
oh, I'm sorry.
yeah.
So Sencha just wraps it in like a browser pane. It's literally just like a skinless browser. But that's just an example. Like if you could wrap, Node is its own application, and Sencha you can think of as its own application. But you could memory profile that rather than worrying about JavaScript at the JavaScript runtime, using an API to like call the mobile device and say, how much memory is this specific application using, and then you have a much better idea.
Yes, you can know potentially how much memory your heap has consumed at some point before it decided it was going to free space, but that doesn't help you free any of that space.
Oh, no, I understand. I just meant that that's the only strategy that I've used to try to kind of limit how much memory I started to allocate. Like, I would basically halt and not, I would put up a loading icon and just go, I'm not going to tell them why, but because the app's not loading anything, it's really just waiting for the GC. So I was just wondering if you had any experience with that.
Not really. We try not to create garbage as best we can and cross our fingers.
Hey, have you experimented with ASM.js at all? And what if?
Yeah,
What do you
so,
think?
well, actually, not in any game that we've had. I personally have played around with it a little bit, and I think that it's really neat, and ahead of time compiling. So I don't know. I guess if anyone is not familiar with ASM.js, it's pure JavaScript. It's nothing special in terms of the syntax, but it has it's actually a subset of JavaScript, and it allows a browser to do ahead of time compilation on your code unit, because it enforces strict types by casting. Basically, there are some weird rules where bitwise operations force a number to be a 32-bit signed integer, I believe, and then everything else is a double, unless it had a bitwise operation. Hooray! But yeah, it basically allows the browser to do ahead of time compilation, and I think it's being spearheaded by Mozilla, and it's actually in shipping versions of Firefox now. We haven't really tried anything with it in production because performance isn't typically, like the actual runtime speed of the JavaScript isn't really our issue, especially on desktop. We have no problem. It's mobile. That's a real big issue. But especially when you go to WebGL type applications, we're really pushing the browser. It's very important. And it looks cool. It's basically a different language at that point, though, right?
Yes, I was just a bit curious. Have you played with Google Dart at all, or what's your take on what they're doing and whatnot? I tried for a second, and I found it was kind of immature at the time, and the documentation was kind of whack. But
I haven't looked at Dart at all.
Hmm?
I haven't looked at Dart.
Yeah, it's
At
kind
all.
of strange. Okay, that's fine.
I sort of have a comment / question, and I'll preface it by saying I am not an engineer. Okay, I'm a layperson, but I'm listening to you talk up there, and it just sounds like HTML5 development's not a lot of fun. And it sounds like you're Scotty trying to boot up the warp drives without enough dilithium crystals all the time. I mean, what? Is there sort of a bullet point list of things that you have that are like, what are the big issues that you're facing in HTML5 development? Like what memory leakage and memory management obviously is a problem, but man, it just doesn't sound like a fun proposition to me.
I mean, yeah. So I can give some. Well, I think I pretty well illustrated several of the cons. So maybe I'll say a few pros.
Yeah.
So for example, I don't know if any of you were trying to release an update or a new app in the last couple of weeks. Apple had some downtime. We patched our game 4 times. We throw up an app, like we actually run through an app, but we don't need to submit to Apple to do updates to it because it's JavaScript and you're allowed to update that at any time. So that's really our biggest benefit is we can, the cross-platformness of it is actually, it's not all a lie. It does work that way. We write the same code once and it works in desktop and mobile at the same time, and we can keep our game in sync across all the app ecosystems. Android wouldn't really be an issue, but it's iOS that's the big one. We don't have to wait for approval. We just push whenever. So that's probably the biggest pro. Okay. Other pros, I mean, it's getting better. You look a year ago from where we started, which is a lot of the hate in this particular talk is from then, because that's when we started, and it's gotten a lot better. And ASM.js is getting much faster. Things are getting better, but it's really the ability to control your destiny with respect to content updates, and that's pretty much the big one.
I have a question. You talk a lot about development, but what about testers? Do they love HTML5 or do they hate it?
I don't know that I've ever talked to a tester and had them love anything, but that's usually because I'm breaking the things that they're testing. But I think that especially our testers, we've introduced them to the console, and it's JavaScript, right? You can just pull up in a console and poke around with stuff. And so they've been really useful for us because they'll give us a stack trace, or they'll say, here's a few snapshots of my state. This is what's going on. I did this, and here's a console dump, or it's still running. I have the debugger paused. Come look. That's nice. But also we can throw in special functions and stuff, and they just call them. So from a tester who likes to get involved with development point of view, probably they're much happier. I think it's actually, it's pretty easy to pick up JavaScript. Lifetime to master type of thing.
Yeah.
Chess. So yeah, I can't really speak to whether or not they are happier than if they were doing something different, but they seem happy.
I think that was Othello. Easy to learn, lifetime to master. Othello.
I don't know.
Hi. Since you're using JavaScript,
Yeah.
what do you do about security? If your game has like a server component and the user can essentially decompile or look at the JavaScript, is there any extra security that has to go into place because of that, or do you just say, hey, our servers have got the security, so don't worry?
Yeah, we don't.
Fair enough.
That's our take on security, pretty much. That's not entirely true. There's payments and things that happen, and that's actually done in native code. So on Facebook, we do it with Facebook's API, and you have a whole client to Facebook to client to us, from us to Facebook to us to them type of nonsense. And yeah, I mean, the parts of the servers are pretty well locked down, just like in anything else. But no, I mean, yeah, you can decompile the client, so, and we know you can, so we don't try. Because you can't stop, it's literally impossible to stop someone from doing that. Like we have minified code, it's not obfuscated really, it is mangled, so it's more difficult to figure out what's going on. But people publish a new JavaScript library and I'll go pull it and de-obfuscate it and have a look, because why not?
Anybody else? Questions for Chris? If not, let's thank him. Let's give him a big round of applause. Thank you, Chris.